let's start with a new chapter, that is circle. Okay, so today we are starting a new chapter, that is circle. And first of all, what is circle? What is a circle? Now we have seen a figure. Whenever we talk about circle, so this is the figure that we make. Okay, so how can we define a circle? From this fixed point, okay, there are so many. Okay, these all points, when we join these all points, which points? These points. Okay, when we are going to join all these points which are equidistant from this particular point, okay, so it is called a circle. Okay, you can see a proper definition. Okay, a circle is a collection of all points in a plane which are at a constant distance, okay, from a fixed point. Okay, these all points are at a constant distance from a fixed point, say O. Okay, these points A, B, C, there are so many points, in fact. Okay, there are not only these points, there are so many points, okay, which are equidistant from the point. Okay, and it is on a plane. Okay, because this is a two-dimensional figure. Okay, this is on a plane. A circle is drawn on a plane, on a paper, a two-dimensional figure. Okay, because if you are drawing a circle in a three-dimensional figure, then it is a sphere, not a circle. Okay, now here you can see here. Now some of the common things in circle that we see, that is, if this is a circle, okay, then this is a what? Radius. And when we are going to join two radius, one means just opposite to another, then this is called the diameter. Okay, yes, this is the center, this is the circumference. Okay, now there are many more definitions, okay, related to them. Now let's see some important terms that are related to circle. Okay, these terms you have been seeing till now. Okay, you have been listening, and you have been like, whenever you find out the area of a circle, then also you come to know, you have listened this word: center, radius, diameter, circumference. Okay, but other than this, there are many more terms that are related to circle, that is chord, semicircle, circumference. We have already, actually, what is circumference? The total length. Okay, this total length, जो पूरी length है ना, ये आपकी, ये पूरी length जो है, ये आपकी circumference कहलाएगी. ठीक है? Okay, now what is a chord? Okay, when you join two opposite points on the circumference, okay, that is a chord. Okay, so I said two opposite point. Okay, this is a circle and I am joining two opposite point on this. Okay, so this is what? A chord. Okay, and diameter also join two opposite points from a circumference, so this is also a chord, but this chord, yeah, is the longest chord. Okay, longest chord, diameter. Okay, Safia, so the chord diameter is the longest chord of a circle. Okay, the definitions are all given here. Okay, a line segment joining any two points on the circumference of a circle is called a chord. Okay, understood? And diameter is the longest chord of a circle. Now semicircle, the half circle. Okay, semicircle means just if you are going to cut the circle into two half, that is from the diameter ke up the rest half. If, okay, for example, if this is a circle and this is the diameter, then this half portion is a semicircle. Okay, and this half portion is again a semicircle. Okay, so you can say this is a semicircle. And we will see one of the property, that in a semicircle you will find an angle 90 degrees. Okay, we'll see in properties. Okay, so now if you see the definition of semicircle, a diameter of a circle divides into two equal parts or in two equal arcs. Okay, each of these two arcs is called a semicircle. Okay, arc means this portion. ये जो आपको curve होता है ना, this is called an arc. This is called an arc. Okay, and if you are representing this arc, so like PQR, you are representing PQR as an arc. So you have to use this symbol as arc. Okay, PQR arc. Now here you can see a definition of arc also. A continuous piece of a circle is called an arc. Okay, in adjoining figure, the figure that you can see here. Okay, in this figure, P and Q are 2 points on a circle which divided into two equal parts. Okay, not here P and Q are not dividing into equal parts. It is just dividing the circle in two parts. Okay, if I'm drawing here a circle, okay, and there is a line. This is a point here, and this is a point here, P and Q. If I'm going to join this PQ, so this PQ is actually dividing the circle into parts, okay. It is not equal, but there are two parts. Which two parts? The upper part and the down part, okay. So I am writing here any of this. You can PQR, you can mark here, and here you can mark it as A, B, any other symbol, okay. So the if you are going to if you want to represent this portion, this blue portion, okay, this one, so you can represent it as PRQR, okay. This arc symbol, when you are going to draw, so it will resemble an arc, okay. And PAQ is also an arc, okay. Now you can see the above arc is the bigger one, okay. This one, the first one is the bigger one, and the second one is the smaller one. So this is a major arc, and this is a minor arc, okay. Major and minor, okay. Major is the bigger one, and the minor is the smaller one. Similarly, segment. Now, segment is what? A region between a chord and either of its arc is called the segment of the circle, okay. If circle ka here, I'll show you here segment, okay. Now, if you are drawing a line from here, okay, so what is segment? This is a chord. This AB is what, Safia? This AB is what? It is a chord, okay. It is joining two points on the circumference, okay. So this is a chord, and this below portion AB is an arc, okay. AB is a chord, and if I'll mention here as Q, so AQB is an arc, okay. Now the region between this, okay, the region between this region is called the segment, okay. The region between the chord and the arc is called the segment. Here also there is major segment and minor segment, okay. This one is what? Minor segment, the smaller one, minor segment, and this one is called the major segment, okay. Major and minor segment. Now sector. Now sector is between the arc and the two radius, okay. If from the figure itself you can see the region between an arc and the two radius, okay, joining the end of the arc to the center is called a sector, okay. Now if I am assuming that this is an arc, this arc I am taking, so from the end point of this we are taking the radius which is joining the center, okay. So this is A, this is B, this is O, the center. So here this is what? Minor arc, and this is what? Major arc, okay. The same thing for arc, sorry, a major sector, not arc. Explaining about sector, major sector, minor sector, okay. So you have, if you are representing sector, you can write for both the sector, you can write A or B only, okay. But if you are representing minor or major, that you have to explain that you are representing the minor sector or you are representing the major sector also. Like if I'm representing a if I'm representing the angle, okay, ABC, okay. So if I'm saying angle ABC, okay, so that can be this angle also, or it can be this angle also, okay. ABC is going to represent both the angle, okay. So here AOB is going to represent the sector, but you have to mention you are representing the minor sector or the major sector, okay. Now these terms are clear, Safia? Sector, segment, chord, arc, circumference, semicircle. Any doubt in any of this?
Yeah.
Now, some of the important results that are related to circle, okay. So what are the important results that are related to circle? The first one, the perpendicular drawn from the center of a circle to a chord bisect it and vice versa, okay. So that means that this is a chord, AB is a chord, and it is saying that if you are drawing a perpendicular from the center of a circle, if you are drawing a perpendicular from the center of the circle, then this is going to bisect the chord, okay. So it will be equal. This is the result of your results related to circle, okay. So whenever you see any type of question where it perpendicular is drawn from the center to the chord, then that chord is being bisected with that perpendicular, and vice versa means if a chord is bisected from a line through the center, so that line is actually a perpendicular, okay. This is for your first point, okay. Now, equal chords of a circle are equidistant from the center, okay. So all the equal chords. If I'm saying that this AB, okay, AB is equal to CD, okay. If I'm saying that AB is equal to CD, then it is equidistant from the center. Therefore, यहाँ पे P लिख देते हैं, यहाँ पे Q लिख, therefore OP will be equal to OQ. Okay, this is the result of your many of the theorems. Okay, so equal chords of a circle are equidistant from the center. Okay, if the chords are equal, then their distance from the center is also equal. If the chord length varies, okay, then their distance will also vary from the center. Okay, now the angle subtended by an arc. Now here the figure is already I have drawn. Okay, just clearly look at this figure. Okay, see, the angle subtended by an arc or corresponding chord at the center of the circle is twice the angle subtended by the same arc at the point on the remaining part of the circle. Okay, so if you are drawing a chord, if it is a chord, okay, this is your center. Okay, so the angle that this chord is making at the center, okay, like it is theta. Okay, so the angle that the same chord, I'm not making any, I'm choosing not any different chord. Okay, the same chord is going to make the angle at any of the point is half of this. Okay, is half of this angle at the center. Okay, if you're making here, okay, with the same chord, the chord should be the same. Okay, but this is the angle theta, half by half. Okay, so it written here, the angle subtended by an arc at the center of the circle is twice the angle subtended by the same arc at any point on the remaining part of the circle. किसी भी part circle के किसी भी part पे, if you are going to make an angle, okay, with the same chord, then that angle will be what, half of the angle that the chord is making at the center. Now, equal chords of a circle subtend equal angles at the center. Okay, like equal chords are equidistant from the center, they are going to hold equal angles at the center. Okay, the angle in a semicircle is a right angle. This is a semicircle, so the angle in the semicircle is the right angle. Okay, whenever you are making an angle in the semicircle, it will be a right angle. Okay, angles in the same segment of a circle are equal. Okay, angles in the same segment of a circle are equal. If the segments are same, then your angles, yeah, in the same segment, the angles will also be same. Okay, if you're taking the segment same, then your angle will be same. The sum of any pair of opposite angles of a cyclic quadrilateral is 180. Cyclic quadrilateral means a quadrilateral drawn inside the circle, okay, but all its your vertices should touch the circle, okay, then it is a cyclic quadrilateral. Okay, so the opposite angle sum will be equal to 180 degree. Okay, if you are adding opposite. Okay, so this plus this will give you 180 degree, and this plus this diagonal. Okay, the sum of any pair of opposite angles of a cyclic quadrilateral is 180 degree. Okay, now if two circles intersect at 2 points, okay, if two circles are there that are intersecting at 2 points, then the line through the center is the perpendicular bisector of the common chord. Okay, now what it is saying, two circles are there. Okay, one is this circle and one is this circle. Okay, so they are actually meeting at 2 points. Okay, this and this. Okay, so the center is here, its center is here. So if we are drawing a center, so that is going to bisect it. Okay, you read here, a line AB at, sorry, where, if a circle intersect at 2 points, okay, the center is intersected, then the line through the centers is the perpendicular bisector of the common chord. Okay, so the common chord will be what, from these 2 points, from the 2 point where they are touching, this is the common chord. So this common chord has been bisected from the line which is joining the centers of the circle. Okay, so that means this is equal to this. Okay, this is some of the results of the circle. Any doubt in any of these points, Safia, from among 8 points? Do you have any doubt in any of them? Safia, do you have any doubt in any of them? Now, tangent to a circle. Okay, in your class 10, only tangent to, mainly tangents is covered. Okay, now what is a tangent? Okay, So tangent is a line. Okay, before that, let's see it. Okay, so suppose a line is there and a circle is there. Okay, so there can be three conditions. If we are taking a line and a circle, you can see here there can be three possible cases which can arise according to the position of line AB with respect to circle. Okay, so what are the three possible position that can be there? Okay, here first one you see a circle is there and the line is there. Okay, but they are not touching at all. Okay, so that is non-intersecting line. Okay, it is a non-intersecting line. Case one is when there is no common point between a circle and a line AB. In this case, the line AB is said to be non-intersecting with respect to the circle. Okay, now the another case that it is cutting the circle, okay, at 2 points. Okay, it is touching, not touching, it is cutting the circles at 2 points. Okay, or you can say touching. Yeah, when there are two common points P and Q between a circle and a line AB. In this case, line AB intersect the circle at 2 points. So this line is called the secant of the circle. Okay, then it is called what? A secant of a circle. Okay, AB intersect the circle at 2 points. When it is intersecting at 2 points, then it is called the secant of the circle. Now the third condition is that when there is only one common point between a circle and a line. Okay, between a circle and a, in this case, the line AB is the tangent to the center, to the circle at point P, where it is touching. Okay, so when tangent is what? A tangent is a line which is touching a circle. Okay, just touching a circle at a single point. That is called the tangent of the circle. Okay, understood what is tangent of a circle, Safia? You can see here the tangent, and P is what? P is the point where it is touching the circle. So that particular point is called point of contact. Okay, tangent is a circle, is a line that intersects or touches the circle at only one point. Okay, tangent, that is a line that intersects or touches the circle at only one point. Okay, the common point of the tangent of the circle is called the point of contact. Okay, the common point है आपका where the circle is touching the tangent, that particular point is called the point of contact. Okay, also we can say that the tangent to a circle is a special case of the secant. Okay, obviously there is a special case of, in secant what happened, there were two places where the line was touching the circle. Okay, so you can assume that both the points have come together. Okay, they are coinciding. Okay,
Can you
so
show second?
yes, Sophia.
Can you show second?
Yeah, here only. See, this is your second. This AB is your second. See, AB intersect the circle at 2 points. So this line is called the secant of the circle. Okay, understood? Any doubt?
No, ma'am.
Okay, instant. Yeah. So that 2 points in the second, that 2 points are actually coinciding. Okay, it has come to only 1 point. Okay, so that statement is only written here. Also, we can say that the tangent to a circle is a special case of the secant when the two endpoints of it correspond to its corresponding chord coincide. Okay, now there is only one tangent at a point of the circle. Okay, there will be only one tangent to that point of the circle because tangent is touching at a single point. Okay, so there will be one tangent only. A circle can have maximum two parallel tangents which can be drawn to the opposite sides of the center. Okay, now tangent can be many. Okay, but parallel tangents will be how many? A circle can have maximum two parallel tangents, okay, which are drawn to the opposite sides of the center. Center के opposite sides पे draw किया हो गया. Then only there will be called a parallel tangent. Okay, parallel means they will be equal. This is the center, opposite sides of center. So you can choose this point, this particular point, and just opposite to that this point. Okay, so if it is not touching, sorry, so it is just simply touching. Okay? So there will be only two parallel tangent. Either you can draw from here, okay, you can draw from here, okay. So in this pair, only two will be there. This, I should have used different color, this or you can say this or this, okay. So these 2 points are also very important. Okay. Now, what is the length of the tangent? Okay, the length of the tangent of the the length of the segment of the tangent between the given point and the point of contact is called the length. Now, if your given point is your B and see A is what? A is the point where this tangent is touching the circle. Okay. So from point of contact to the given point, what is your length? That is called the length of the tangent. You see here, segment of the tangent between the given point B and point of contact A. That is called the length of the tangent. AB is called the length of the tangent. Okay. Now, properties of a tangent. In properties of a tangent, only one theorem that we are going to cover here. Okay. Now, what is the theorem? The tangent of any point of a circle is perpendicular to the radius through the point of contact. Okay. Now, what it is saying? Just listen. The tangent at any point. Okay. From any point, if you are having a tangent at any point of a circle is perpendicular to the radius through the point of contact. Wait, just is no problem. Just okay. Now this is your radius. Okay, and I am drawing a tangent here. Okay, so this tangent will be perpendicular to this radius. Okay, that is written here. A tangent at any point of a circle is perpendicular to the radius through the point of contact. जो point of contact है where they are meeting, okay, the point of contact where they are meeting, that at that point of contact it is perpendicular to the radius. Whether your radius is here and you are drawing a tangent here, then also it will be perpendicular. Whether it is here, okay, anywhere it will be perpendicular. Okay, understood, Safia? Now we are going to prove this only. Okay, that how this theorem works. Okay, and the vice versa will also work. Okay, vice versa means just the opposite. Now here the given is what? A circle is given with center O and a tangent AB at point P on the circle. Okay, so a circle is given with a center of O and a tangent AB which is touching the circle at point P. Okay, so this is given to us. Now construction that we are doing here, we explain you here only. Okay, now okay, so A, B, this is P, in center. Okay, this is your radius. Now the extra construction that we are doing, that is we are okay, we are OQ. Okay, we are taking a Q point. Okay, we are taking a Q point. Take any point Q other than P. Okay, other than P, we are taking a point Q on the tangent AB. Okay, and we are going to join this OQ. Okay, this
Now,
OQ.
how have you constructed the tangent?
Yes, Afia. Can you repeat?
How have you constructed the tangent?
When I construct this AB is the tangent.
And what will be the properties for that?
What will be the properties of the tangent? See, which line is called a tangent? There can be so many lines. The tangent that see, tangent is a line which is drawn outside the circle. Okay, and it is touching only at single point. Circle के एक single point पे touch कर रहा होता है. ठीक है, वो line जो circle को एक point पे touch करती है, that particular line is called a tangent. Okay,
Yeah.
understood? And there can be so many, there can not only be one tangent. In the second part, we will study how many tangents can be drawn for a circle. Okay, but here, what is a tangent if you're asking? So tangent is a line that is drawn outside the circle, which is touching the circle at a single point. That is called the tangent. Okay, so that single point where the tangent is touching the circle, okay, if you're drawing the radius, okay, so that line, the tangent is actually perpendicular to the radius. Okay, so this angle will be 90 degree. Okay, but how this angle will be 90 degrees, so we are going to prove. Okay, so for proving purpose, we are taking a point Q. Okay, we are taking a point Q which is not P. Which is not P means that will not be touching. Okay, so this line, where this line is touching the circle, we are going to take it as R. This point we are going to take it as R. Okay, now Q is a point on the tangent. Okay, AB. Now this point is not P. Okay, that means this point Q is outside the circle because only P is in, you can say P is on the circle. Okay, because P is the only point which is touching the circle from this line AB. Okay, so this Q point is any point on the tangent. So this is outside the circle. Okay, so this is a point. Okay, so what I was explaining. Yeah, so this is a point which is outside the circle. Okay, now, and yeah, if this Q point is on the circle, then AB will become a second, not a tangent, because second is a line that is touching the circle at 2 points. Okay, second is a line that is touching the circle at 2 points. So if this Q point will lie on the circle, that means 2 points will be there, P and Q. Yes, Apia? There 2 points will be there, P and Q, which will touch the circle if this Q point is on the circle. So therefore, this will not be a tangent, it will become a second. Okay, so this is Q, this Q is outside the circle. Okay, this is sure. Okay, now let's see.
So till now we have done construction.
See, construction we have done only this much, that we have taken a point Q, okay, on a tangent AB, and we have joined this Q point on OQ. Okay, I was telling that this point O cannot touch the circle because this is a tangent. Okay, and if Q is also touching the circle, that means it will become a second, because P is also a point that is touching the circle, that is already given to us. So this Q is lying outside the circle. Okay, it is on the tangent. Now if you see the this OQ, we are taking this OQ is touching the circle as R point. ठीक है, R point पे वो circle को touch कर रहा है, because Q is outside the circle. So somewhere this line is touching the circle, and where it is touching the circle, it is touching the circle as at R. So this OP is equal to OR, because it is a radius. It will be radius of the circle. Yes or no? OP and OR will be the radius of the circle.
Yes.
Okay. Now, if you will see OQ, if you are talking about OQ, so we can write OQ will be equal to what? OR plus RQ. Yes.
Yeah.
Okay. That means OQ is greater than OR, because we are adding something in OR to get OQ. Okay. So OQ is greater than OR. Yes. And OP is also radius. So that means OQ, OP and OR equal. So that means instead of OR, we can write OP. So OQ is greater than OP. Yes. Or other way you can say also, just reverse thing also, you can say that OP is less than OQ. Yes or no? So that means OP is the shortest distance. Actually, this all thing I explain you because OP is shortest distance between the point O and the tangent. Okay, so the perpendicular is what? Perpendicular is the shortest distance between the point and the line. Okay, you can read here. I have already written here. See, thus OP is the shorter than any other segment joining O to any point AB. Also, we know that the shortest distance between a point and a line is perpendicular distance from the point to the line. So OP is perpendicular to AB. Any doubt here, Sophia?
No, ma'am.
No doubt. Okay. So, and here its converse is also true. Now, what is the converse? Means just the opposite thing. That is a line drawn through the end point of a circle. If you draw a line through the end point of a radius and perpendicular to it, it is a tangent. Okay. So if we are drawing a line that is from the end point of the radius, okay, and radius के end point से अगर हम एक line draw करते हैं जो कि perpendicular है radius पे, so that line will be a tangent. That means it will be touching at single point only. Okay, understood, Sophia?
Yes, ma'am.
Okay. Now we'll just quickly see this question and then we can end the class because it's already 46. Okay. Now a tangent PQ at a point P of a circle. Okay. PQ is a tangent. You can see the diagram. So it is touching P, and it is written here. P is the point of contact. Okay. So P is the point where it is touching. And since it is a tangent, so it will be perpendicular to the radius of a circle. Radius 5 centimeter. Radius is 5 centimeter. Meets a line through the center O. Okay. At a point Q such that PQ is equal to 12 centimeter. Okay. So PQ value is also given. Now, can you find out the length of OQ, Tapia? Can you find out the length of OQ? This is already we have done. Now, see here. This is the radius and this is 90 degrees. Okay. And this, so if it is 90 degree, so it will become what? Right angle triangle. So we can apply the Pythagoras theorem. Yes. So OQ value OQ square will be equal to OP square plus PQ square. Yes, Safiya? Any doubt in this, Safiya?
No, ma'am.
Okay, so after applying the Pythagoras theorem, okay, so you can get that 5 square plus 12 square. So we are getting what? 169. So OQ square is equal to 169, and 169 is a square of 13. So OQ will be equal to 13. Okay, we'll get plus minus 13, but since we are talking about the distance, we're talking about a value, so it will be positive 13. So 13 centimeter. Okay, understood, Safiya?
Yes, ma'am.
Just, okay, so just go through this topic. Okay, we are having some more questions here. Okay, in your handouts, H1, you can go through it. Okay, and I will upload this lecture PDF also. Okay, okay, bye bye for today.